let's start. So basically we need to set up a couple of things. So first of all, let's have plane, maybe a bit larger size. Like this. And we call this one as ground. And let's make cube as a start. Is that? Maybe this symbol is better. So, and then I'm going to duplicate this one. And I'm going to put somewhere else here. And I'm going to call this as a goal. And let's create a folder because it's quite invisible right now. So let's change the materials. So material, around material, I'm going to give them a bit like dark gray. Maybe just thinking a little bit of blue as well. Not this much blue. Have something like this. And then I'm going to make the a start and the goal. Create another material. Again, red material and blue material, most typical. Oops. So I'm going to say the red is going to be end point and blue is going to be start point. So like this. So, and then I think this is, I think we are ready to use this. So we're going to create new empty object, create empty, and let's change the position. We're going to call this one as a waypoint. Oops. And actually, I'm going to create one more empty object, which is waypoint, waypoint. Oh, and let's put this waypoint child of waypoints group. And then this waypoint, not group, the waypoint, let's change the icon for this. I'm going to use just to see very easily visible, yellow diamond. And if you don't see it, wait, you can change the size of gizmo over here. Main camera, I don't want to see this one here, so I'm going to just align my my camera. So now we're also going to have this same view here. And actually the sunlight, the location of sunlight is not that important. So I'm going to just move away from my scene. So yeah, this is our, it's going to be our waypoint. So, and then we're going to put a couple of them. I don't like this kind of reflection. So I'm going to just, yeah, move out the smoothness of the material. And this one, so we said here is a start point and then here is the goal. But however, this time is a bit deep because the idea itself is a very different from the nav mesh, because nav mesh is actually we only going to say there is a goal and then it's going to find their own way to get there. But this waypoint system is more like the object, the agent is directly heading to the waypoint. So I said just this is goal, but it's not goal anyway, before I give them the waypoint itself. So first of all, I'm going to just copy paste this waypoint. So maybe agent start from here, and then it goes to here, here, something like that. Like maybe this. Something like this. So it ends up, so we expect our the agent is going to move from start from here and then go up in like this way. So maybe I think I can move a little bit, give a little bit of difference. So like this. I don't know, maybe something like that. So, and then it's going to read the all the waypoints as a sequence from here to just following the numbers from top to the bottom. So just remember, just make sure that the all of these are just in order which you want. So let's create and then okay, maybe. Yeah, sorry. Because I mean, you can do like this, but it's better to make them as a prefab actually, is to avoid some error later. I'm going to make the folder prefabs. I'm going to make this waypoint as a prefab, and then just going to copy this waypoint again. I know it's a bit different from just before. So we have this waypoint. And then let's create capsule as our agent. We want to make it start from somewhere else here, right? So, and then let's make this one as a prefab as well. So later, this agent, we're going to follow each the waypoint like this. I don't remember exactly, but yeah, something like that. So let's create some script. Gonna call this script as waypoint. We're going to attach this script to here waypoint group, and not to the waypoint, just waypoint group to parents. And then let's write something. So actually, this is going to be very simple. Well, we're not going to use start or update, and let's uh, like public static. We're going to create the static transform play waypoint. So this is going to contains all the waypoints as the array, and then we're going to create the void awake. So awake is actually how can I say that? It's the same, very similar to start. It's only going to play once at the beginning of the frame. But however, the one thing different from the start is like a start is going to do something right after the frame started. But like awake is just, it is going to do this one just right before the frame started. So this is like the most priority script to read to the system. So we're going to do the awake, and then the waypoints array is going to collect transforms uh, child count. So this is going to count all the child of the transform, because we attached this script to waypoints group. So it's going to read all the child of this transform, and
Hey,
then
Han.
mhm,
Quick question. When you say public static transform, so you're creating an array called transform, or transform belongs to like just like a, let's say like a certain property of Unity, like it
I
contains
mean
like position or
transform. You mean
yeah, like is it just
transform?
like a variable
Hmm.
name or is it something else?
I mean, it is kind of the game object. And actually, when you see the any game object over here, it contains transform, right?
Mm-hmm.
So it's a bit different from the game object. Game object is like it includes everything, but the transform is more like how can I say that? Uh, we used to use transform a lot, right? I mean, for example, we're going to when we instantiate something, and then we want to make a child of the transform this object, and then we used to use like this dot transform, something like that, right?
Mm-hmm.
So transform is like it's a bit hard to explain about the exact explain for this, but uh, it's one of the can say that variable of game object. So it's a bit different from the game object, but
Mm-hmm.
anyway, it's going to read as it's almost same. It's almost same, but transform reads is leads more about the data of this position, about the
Mm-hmm.
position and location scale, these kind of things, rather than just older information, all the variables inside of the game object, like renderer, idle, collider, those kind of things.
Okay.
Okay, so yeah, we're going to make a for loop because we want to check all the tiles. So here, waypoints length. Then we're going to add to array equal to transform now. Finally, it's going to get the child. So this is just so yeah, I just made this is just counting the number of the child of this transform. So but now it's only going to get the number like it's a 10 over there. And then now finally it's going to get each child the data of each child by doing this one. So it's going to go one by one, and yeah, I'm going to save this one. So yep. And again, I'm going to create another C# script. I'm going to call this one as agent controller. Okay. And I'm going to attach that agent controller, not this one. We don't need this one anymore. I'm going to just attach our agent controller to Maybe let's see how it works. So maybe we can just have our agent over here. And but however, I'm going to put our, where is it? Script agent controller to our agent. This one, okay, already contains. Cool. And then in the agent controller, uh, we're going to, first of all, we're going to give them a speed. So it's going to, yeah, it's going to have its own speed. Like, so I'm going to call public float speed, maybe let's say 10. And then, yeah, we're going to use the transform, which is target, which is going to be our waypoint. Then again, private integer. This is going to be the index of each point, and we're going to calculate it inside of the code. So I just call this one point index. We can start with the 0. So here, these two variables, we're not going to control inside of the outside of the script, and then we only can control this float speed. So here, so we can say oops, did I do? Target is waypoints dot waypoint 0 at the beginning. So we just called this waypoint, and then as this is static, so yeah, that's why we can call from outside of the script. So we just called this waypoint, and then which is the first one. So it starts from the first one, and then here what we need to do is just give them some vectors to move around. I'm gonna call, skip the vector 3 direction is it's we're going to use this, each waypoint is location, right? So times get sorry, position, and minus transforms position, which means the current location of agent. So it's going to start, the direction is going to like from the current location of the agent and toward to the waypoint position. And then transform that, we're going to change the location of the agent to direction normalized and speed with this speed. And then again, we're going to add, well, you can just, yeah, finish like this. But however, it's better to add, in this case, it's better to add, oops, time, that delta time. Because like if we don't have this one, anyway, it leads the speed, but like every computer has a different frame rate. And then sometimes if I run like a very complicated things, and then like if the project is very complicated, the calculation of frame rate is different. So to make the speed same in every single computer or every single project, it's, in this case, it's better to just multiply time dot delta time. So this is like the time of the system. I think that's the easiest way to understand, I guess. So if I save this one and then play, yeah, you can see that our agent is moving toward to the first waypoint here. This, and then of course these are gizmos, which means like it's empty object, but we only put the icon to recognize where it is, so you cannot see that inside of the game view indeed. And then so what we need to do is we need to just find each position, and then it can so it can constantly moving, right? So we're going to add a couple of more sentences. So first of all, inside of the update, if when the agent reached to the waypoint, then it's going to get the next point. That's what we want to do, right? So if vector 3 distance, and which distance is the position of the agent and the target. I think we used this concept yesterday as well, right? So if it is smaller than, I don't know, maybe like this, now it's going to find the next position. It's going to get the next waypoint, right? And then Alt Enter and generate method. Here we have the get next waypoint. So inside of this function, what we're going to do is just, so actually the point index is going to increase every time, and then every time when the agent reached to the waypoint, and then target is going to, so this one you can just copy and paste this line, but this time we start with the 0, but after that it's going to increase. So we can just use the point index, and then the target is going to keep changing. So I'm going to save this one. Then if I run this, so now you can see the agent is moving around by following oh, did I do like that? Sequence of the waypoint. And then you will see the error when it leads the last one, because when it leads to the last one, yeah, it cannot calculate anymore, and then it's not exist. So, well, I mean, you can do like different things. You can play with your numbers, but for now, maybe I want to make this one is disappear inside of the goal. So let's assume this is like it's entering to somewhere. So what we can do is just actually, we can just add if state, and if point index is rather than, oops, rather than waypoint dot waypoint dot length -1. I think this, yeah, this is avoid to error. Oh, yeah. And then all you need to do is just destroy the object. So it's not going to, yeah, destroy this game object. So it's not existing anymore. And then if this is smaller than waypoint at the point index, then yeah, I don't know. I mean, if this is larger than this one, it doesn't need to calculate here, and then destroy and then done. To do that, just what we need to do is just return. So it's not going to calculate. So without this return, well, script itself doesn't have any error, but when it reaches, okay, let's increase the speed a bit. Let's say 20. When it reaches the last one, again, it's going to have an error because the agent is disappeared. But however, it already calculated this one, and which is not exist. So we want to make sure it's not going to calculate the last sentence of this one. And then that's why we need a return over here. If we play this one, so here, there's no more error, and then our agent is destroyed. It's not exist anymore.
Hey, Han.
Mm-hmm.
So when you put like return into like a function, it like just breaks out of it, or or what is kind of like the use of that?
So okay. Well, I mean, there's a couple of like way to use a return. So for example, this time return is existing inside of the if, right? So this function is going to read only when this if state is true, right? Which means if the point index is larger than waypoint length, right? And then if we by using this return syntax, is the how can I say that program usually lead top to bottom, right? So it leads in the this way, the correct to the top to the bottom. But by using this return, it's not going to go underneath here, underneath of the its syntax anymore. So it's not reading these two syntaxes when if statement is true. Do you know what I'm
Mhm.
saying?
Yeah,
Yeah,
yeah. So
yeah,
it's just I guess it stops there. Like it just
yeah. It stops there. Yeah, it
starts at
stops
there.
there. So to avoid error,
Mhm.
we use you can use lots of these kind of things like so if state and then but sometimes it calculates more after the if state. So if you want to avoid that kind of error, you need to use the return in this case.
Mhm. And I had a just another question. I
Mm-hmm.
guess this is more of a seizure because I'm like a little bit newer to
All right,
seizure,
yeah,
but
go ahead. It's fine.
so like for example, where you call waypoints, the waypoint is being referenced like from where? Like is it like
This
from
one, you
above
mean?
and yeah.
This one is from this script.
So and
The
that's where
this
you
one.
call it.
Sorry.
Oh, okay. And
Sorry.
then that's where you
Then
call it like public static transform, and so it references you can reference
yeah,
it
yeah,
from the
yeah,
other
yeah.
script.
To use outside of the script.
Okay, gotcha.
Yeah. So the public static means without static, well, you can use it anyway, but there is I can say that if there is going to be error, I mean like so to use your some like specific data, specific value from outside of, I mean, from another script, you need to have this setting. If you want to call, yeah, actually, yeah, it's better to say call. It's calling these waypoints, right? Waypoints from inside of this waypoint script, waypoint class.
Mm-hmm.
So we're going to call the waypoint class, and then inside of the waypoint class we are calling these waypoints the transform
Oh.
array. But however, to use this transform in from the other script, this variable need to be steady.
Mhm.
Do you know what I'm saying?
Yeah, yeah, I think I get it now.
Mm.
Okay, yeah.
Cool,
It's
cool,
just
cool,
like
cool.
so you can reference the same class on the other one, right? That's
It
pretty
is,
much
it
it.
is, it is.
Okay.
Yeah. Cool. And then so now what we want to do is just maybe we want to have more agent. So what we can do is I'm going to create another empty object, going to call wave spawner. Let's set this one. And then let's create another script, which is wave spawner. And let's attach this script to wave spawner. And this one is also, so since we are using the we are using the transforms, so we are not going to using the game object. We are just going to call the transform itself. Public what's this? Public transform, and which is agent pickup, and again public transform part position. Well, think maybe it's better to say start point. Yeah. Position sounds like the vector. So then public float, because like we want to give like a certain gap in between the older agent. So we're going to call this one time between agent or waves. Waves. Call to maybe I'll say 3 seconds. And again, public float. Countdown is we're going to use these values to like I say that calculate a time between the waves. So I'm going to call this one as 1f. Use a 1f, and then we don't need the start function here. We only need going to use the update, and we're going to create another function. So let's say if the countdown is less than 0, now it's going to create the agent is going to be spawned. So I'm going to call this one spawn agent. Let's create this method. And also the countdown is going to same as the time between waves. And then countdown, we're going to, because it needs to do the countdowns. So it's going to reduce one by one at each, not each frame, each seconds. So time dot delta time. So this means the 1 second inside of the system. I'm saying. Well, if you also can do the real time in startup, these kind of things, but yeah, usually just because if you do that, like I said, yeah, it's going to be different from the every system. So it's better to using the delta time. We don't need inside of this one. And then just all we need to do is just instantiate that transform, which is agent prefab, and then the position of the start point is position, and then start points rotation, and underneath of that's it. Let's delete this agent because we're going to instantiate every agent. And then if you click the wave spawner under the inspector, we need to attach some of them. So we're going to create spawn this agent and then position of, where is it, start here. And then if you play this one, yeah, so every 3 seconds, it is instantiating the older this agent, and then all of the agent is going to follow this waypoint like this. Actually, basically, this idea can be also used to nav mesh as well. But the only the difference between yesterday and today is just how you find the goal, and then how you find the way. That's it, actually. So this waypoint system, actually, you need to give every waypoint where you want to go. So, for example, yesterday the nav mesh is calculating the object by itself, right? But this one, if I create the new cube, then, oops, yes, if we have this kind of uh, the obstacle over here, actually, it's nothing. What I'm saying is they're going to just completely ignore this obstacle, even though it has a collider like this, because this waypointing system cannot recognize this object, I mean, this obstacle anymore at all. So if you want to use this idea, you have to move your waypoint like this. So you have to, this is kind of by doing manually. So that's why the nav mesh is about the AI, and this is just, yeah, this is just manual way to find the simple waypointing, simple, you can say that simple route. Yeah, that's it.
Behind, so
Mhm.
the nav mesh is like it's calculating on the go pretty much. Like as the
Yes,
agent moves, it's like it's able to figure out like if it collides or not.
it is actually. So the nav mesh is just, it is AI. It is like yeah. So it is AI, so it can calculate just the shortest way, and then it can calculate the obstacles, and then sometimes I didn't show it yesterday, but just by adding something and by doing some inside of the navigation, and
Mhm.
you also can, it also can calculate how can I say it, moving obstacle as well, and so on. So but this one is like you need to give the position of the start and then the goal, and then so
Mhm.
this is like a manual way to give the route. And then Navmesh, we don't give the route, we only give them the area they can move, and then the start point and then the goal point. That's it. And then
Mhm.
the system, we're going to calculate its own route to get there.
Gotcha.
Mm, cool, cool. So, okay, let's save this, and then we can uh, save as this scene, because I would like to just use this scene again, but yeah, just want to save, want to keep this scene as well. So I'm just going to use this scene, and then I'm going to call this, oops, not name, minimap. All right, yeah. So this is also pretty much about the camera work as well. And it's a bit different way to see the camera in your scene. So uh, let's add camera, and then I'm going to call this one as, oops, mini minimap camera. Then let's move this camera. Let's rotate this camera, because minimap is usually looking at it from the sky, right? So we can rotate this camera, and then let's up somewhere else. It doesn't matter for now, because now it is a perspective view, right? Its projection is perspective, but usually Minimap doesn't have like this kind of perspective view. So we want to have it as an orthographic view. Just change the projection as an orthographic. So now you can see that your camera angle is like, doesn't have any angle, like orthographic view. You can see the difference. So here, all you need to do is just change the size, so you will know where you are looking at it. And then just want to move a bit this. Cool. So now we have the all the views in there. So if we play this one, oops. The reason why you see this error, not error actually, the message is because of, I'm going to make this one, these two a bit down, so it's not going to off from our camera view. All right, it seems like inside of the view. And then because there can be only one audio listener, otherwise the audio going to be like messed up. So inside of the Minimap camera, you need to delete this audio listener. Just remove this component. We don't need it anymore. So now you're not going to see that, yeah, message anymore.